Hello children and welcome to the session today. We have been learning about a series of physical concepts in our book. Now let us understand another important physical component that is inseparable from our lives. It is chapter number 16, electric current and its effect. In this chapter, we are going to learn about electric current and circuit, the effects of electric current and what an electromagnet is. So beginning the chapter, let us talk about electric current. So we have learned from class 6 that if you connect an electric bulb through a wire to a cell, it begins to glow. Why does this happen? Because when you connect a battery, something begins to flow in the wire, which is electric current. That is why the bulb glows. Now, what are these sources of electric current? These sources of electric current can be electric cells, electric batteries. Now, there are very interesting experiments given in your book which require very simple material. These actually tell you how electricity operates. Do conduct these experiments. Now, coming next to the electric circuit. So, this picture that we created here is actually known as a circuit. So, if you see, I have not drawn a cell here, neither have I drawn a bulb here. What have I used? I have used symbols, and these symbols are used to make up the electric circuit. The arrangement of wires, bulbs, cells, etc. in a particular order that allows current to pass through it is known as electric circuit. Let us understand more about electric circuits. Electric circuits have different components such as bulbs, wires, cells, switches, etc. These are called the elements of the electrical circuit. It is difficult to draw an electrical circuit by making the actual diagram of the components. Hence, scientists have devised standard circuit symbols for electrical components. Some universally accepted circuit symbols of electrical components are: making electric circuits. You will need two small size cells, a torch bulb, pieces of insulated wire and adhesive tape. Expose the wire at both the ends of each piece. Complete the circuits by connecting the cells and a bulb in series and parallel. You will see that the bulb glows in both the cases. So, we know that the important components of an electric circuit are a dry cell or a battery, a switch that can be moved on and off, an appliance like a bulb, and conducting wires. Why do you need conducting wires? So that what happens? The electricity passes through it. If the wire is not conducting, the current will not pass through it. Now, we have also learned in the video about the circuit diagram, how the different symbols are used in an electrical circuit. Let's revise them now. We have seen what an open switch looks like, what a closed switch looks like, a connecting wire, a lamp, a battery and a cell. Now, another thing that we have to understand is, in order for the current to flow, there has to be a potential difference. Now, what is a potential difference? If you've ever looked at a battery or a cell closely, there is one positive sign and there is one negative sign on the two ends. The current will always flow from the positive to the negative side. It will always flow from the positive to the negative terminal. What is this? This is the potential difference. Now, when electric current passes through different objects, different kind of effect is produced. You must have seen, if you light a bulb for too long a period and you bring your hand closer to the bulb, it feels hot. So, what is produced due to electricity? Heat is produced due to electricity. And this heat is used in several devices in our house, such as electric iron, geyser, kettle and so on. In case we allow the electricity to pass on continuously in our houses through the wires are also going to heat up, and in case there is nothing to check these increasing temperature, what is going to happen? A fire is going to break out. That is why, as a security feature, we employ an electric fuse in the house. What does this exactly do? Let's watch and understand. A device which breaks the electric circuit if there is an excessive flow of current in the circuit is called electric fuse. It prevents damage to electrical appliances. A fuse works on the heating effect of electric current. A fuse consists of a thin wire of generally tin or copper with a low melting point. When excessive current flows in a household circuit, the fuse wire gets heated and breaks the circuit. A new fuse wire is fitted in place of a fuse that melts. Nowadays, MCB or miniature circuit breakers are used in place of fuses. They are like switches that automatically turn off when current in the circuit exceeds the safe limit. MCB can be reset in the on position. The next important effect of electric current is the magnetic effect. So, an application of magnetic effect is a solenoid. In a solenoid, what is done? A solenoid is a cylindrical core of wire which is made by winding several rounds of laminated or insulated wire over a plastic or paper cylinder. Now, when the electric current is passed through it, the ends of the solenoid begin to behave like a magnet. The same principle is used in the formation of electromagnets. How does this work? Let us watch and understand. Electromagnets can be made by passing electric current through a coil of insulated wire coiled around a soft iron rod. The iron rod behaves as an electromagnet only till the current passes through its coils. Take an iron nail and tie an insulated copper wire around it so as to form a coil. Connect the free ends of the coil wire to the two terminals of an electric cell through a switch. Place some steel pins near one end of the iron nail. Switch on the circuit. You will notice the pins cling to the tip of the nail. When you switch off the current, the pins fall off the iron nail. This proves that electromagnets are temporary magnets. Cranes have strong electromagnets fitted to them that are used to lift heavy objects. Electromagnets are used to separate magnetic materials like iron and steel objects from a heap of junk metal scrap. Electromagnets are used by doctors to remove tiny iron particles from the eyes of people. So, we have understood how an electromagnet works and what are the applications of an electromagnet. So, children, in this chapter, what are the different things that you've learned? You've learned about electric current. You have learned about how the electric current flows from positive to negative. You've also learned about different effects of electric current. Hope you are ready to attempt the questions at the back. Thank you.